Yo, hey, I'm back for some more Codewars. I only discovered this website yesterday and I'm already like thinking about it and just wanting to go back on and do another challenge. I think there's always going to be a need in my life to stretch my brain. Coding challenges, Infinity Factory, whatever it be, gaming. I just like to keep my brain muscle exercised. So this first challenge, I feel like I'm battling some listening to the radio, so I'll just turn that down for a second. This first challenge is sum without highest and lowest number. Okay, so that should be pretty cool. I'm just making a note of so I can chapterize these as well. Some other numbers in a given array or a list accept the highest and lowest element by value, not by index. Okay, the highest and lowest element respectively is a single element. Even if there are more than one with the same value, mind the input validation. Okay, so I presume the array's unsorted as well. I mean, I ought to use terms like list and stuff, but so it's going to come in unsorted. In which case, if an empty value, null, none, nothing, etc., is given instead of an array, or the given array is an empty list with only one element, return 0. Okay. An empty list with only one element, return 0. Oh, okay. So in which case, I'll just test for that. So if array, so if the length of the array is less than 2, just return 0. Okay. Now, maybe I should do an else. I don't know. I don't think it'll only do that if that goes on, and it won't execute the next code if condition is satisfied. So I can just code without an else, I think. Got to find the smallest element in the array, really. So what we can do is we can sum up, but so min is all right. I don't know if we have to initialize that, and max. Maybe we do have to initialize it as a. I don't know if we're going to have negative integers. I'm going to assume that we've just got positive integers anyway. And max, right. So for I in range, for element in array, so for each element in array, if element is smaller than min, so let's put the min to, I don't know, 10,000, something like that. Yeah. So if the element's smaller than min equals element. I don't know what we do if we've got duplicates. If the element is larger than max, max equals the element, right? And then, so that will find us the minimum element. So whatever yo, Yuki, hey, hope you're alright, dude. Just doing a bit of Codewars, by the way. So Python coding challenges. Not sure if you've ever looked at coding, tried it out, whatever. If the element is, so for each element in this list that comes across, right? Oh, cool. Have you tried it in Python or something similar? Oh, cool. Okay. Well, there's these coding challenges. It doesn't matter what language you do them in. Oh yeah. Okay, I know BMNG. Okay, so it's more about the concept of thinking things through than the sort of actual ins and outs of each individual language. So for each element in this array, if the element is smaller than what we set min at, which is 10,000, min is going to become that element. So let's have a look through. So if min's 10,000, 6, the min then becomes 6. And then it moves on and says, is the element smaller than 6? Well, 2 is, so the min becomes the number 2. Is 1 smaller than 2? Yes, it is, so min becomes number 1. It doesn't apply to 8. 8 isn't smaller than 1, and neither is 10. So we've pulled out the min there. And then the same for the max, but the opposite way around. If it's bigger than the max value, so is 6 bigger than 0? Yes. We should pull out the minimum and maximum there. Back to the instructions. Sum all the numbers in the list except for the highest and lowest element. Okay, so we've got the highest and lowest element there. So now, for element in array, we just need a sum, basically, don't we? So sum equals 0. And all I'll do, for each element in the array, I'm just going to say sum. I'll never know which way around to get this. Let's do plus equals the element. In fact, let's not even do it that way. Let's do sum equals whatever the current sum is plus whatever the value is in the element. And then that's it. Almost, because then I need to return sum minus minimum minus the maximum. I don't know about BODMAS there. Not minus the Mexican, it's minus the maximum. Okay. I'm not sure about that, but we'll see. Okay, so I've got an exception raised. If length of array is smaller than 2, so where are we? If the length of the list is smaller than 2, so why does it do like that? Object type, non-type has no length. Oh, okay. So, is that because the test has sent us? Oh, okay. Alright, so if it's an empty array, so if array is that or that, is it like that? Oh. Okay, yeah. Of course, the equal sign in Python is a double equal sign. Otherwise, it's an assignment sign. Okay, so still a little error here. What have we got? Yeah, on to sum array. If the array is that, i.e. an empty array, or the length is less than 2. Non-type. Right, I need to test to see if it's not a type. Then I think if array is none. I've never really used that in Python before. I know that null is a common term. Right, does that like it a little bit better? Oh, I've done the same mistake there. Right. Common mistake in early Python is to mistake an equal sign for an equal sign. Right, okay. So I passed one test. This one here I didn't pass. Only 2 elements, right. So I should have found a -3 and a 0. Because I've got no minus numbers in my list. So I really need to set a minus number. In which case, I'm going to set the minimum amount in the array to be the first value of the array. And I'm going to set the maximum to be the first value of the array as well. Alright, so it doesn't matter what comes in the array. If the array starts with -200 billion, that'll still set the minimum to that and the maximum to that. Let's test that. That should all pass now. Cool. So, back to the instructions then. Sum all the numbers of a given list except the highest and lowest elements. The highest and lowest single elements at each edge, even if more than one with the same value. Okay. Mind the input validation. Right, okay. So, if an empty list, null, none, nothing, etc. is given, instead of an array, or the given array is an empty list or a list with only one element, return 0, which is what we've done there. So that's the input validation. And then this is the real gubbins of it. So, cool. Did you follow along with this, Yuki? And let me just attempt it. Okay, seems to have tested it. Seems to have done all right. So I'm going to submit that and now find a disgustingly simple one-line solution for what I've taken 10 lines to do. Okay, cool. 4 lines. Oh my god. Right, if the array is none, or the length of the array is less than 3, they've gone for return a 0, or return some. Oh, so this they've just used the function of the array. Okay, in Python. So yeah, it's okay. It's very. I mean that function there, max array, minimum array, is what I've like sort of specifically coded up. So yeah, that's all right. What I don't know now is how to get my solution to this Carter. There's my solution. No. If I train again. Nope. Okay. Oh, that's the sensei. Okay. Person who makes it. All right, let's move on to the next one then. Human readable time. Okay. Now this is a 5 Caillou, and I'm sort of wanting to stick around and do them in sequence. So let's just stick with the ones I've been doing so far. I'm going to stick with Python. The difficulty, I'm going to stick with the 8 Caillou, even though 7s were showing up. And some without highest, lowest. Okay, I've done that one. Days in the year. Let's have a look at this one then. Okay, a variation of determining leap years, assuming that only integers are used, and years can be negative and positive. All right, that would be cool. Write a function that will return the days in the year and the year entered in a string. For example, year days 2000 returns the year 2000 as 366 days. There are a few assumptions we will accept. The year 0, even though there is no year 0 in the Gregorian calendar. Right, I didn't know that. Also, the basic rule for validating a leap year is as follows. Divided evenly by 4 are leap years. Exception, century years are not leap years unless they can be divided by 400. So the years 0, minus 64 and 2016 will return 366 days. Whilst 1974 minus 10 and 666 will return 365 days. Okay, all right. That's quite complicated. I wonder when that system was devised. Just to, I think that just compensates for the fact that we take 365 Earth rotations, 365.25 Earth rotations to rotate or to orbit the sun. So that's a hell of a compensation. That probably find out it goes back to like some ancient civilization or something, but. Just making a note of the timestamp here. Okay, so this is days in the year, and I'm just got to find out which years are leap years, basically. Okay, so in order to do that, there's a test, isn't there? Basically, can it be divided by 4? And also, is it a century or not? So the first test is to test whether or not it's a century. So if year divided by, or mod 100, leaves a remainder of 0, if it is a century or not, then we need another case, don't we, really? I might just write another definition in here. Define leap test. And wait. If it's divided by 100, it's definitely going to be divided by 4, because 4 goes into 100. So not only are we testing to see if it's divided by 100, I've got that double equal sign, it's only a leap year if it can be easily divided by 400 as well. Oh, this is silly what I've done there. And 400. Okay, so if it's divided by 100 and 400, it's a leap year. If it's not divisible by 4 under any circumstances, so if the leap year divided by 4 does not equal 0, so if it's not divisible by 4, it's never going to be a leap year, then we're going to return 365, right? Job done. So if it's not divisible by 4. So here we're only getting the stuff that's divisible by 4. And then what we're going to say is, if it's divisible by... Do we need to say if it's divisible by 100? I don't think we do. We need to say... Right, so anything that's now divisible by 4, we don't want everything to be a leap year. We don't want the year 200 to be a leap year. So if it's divisible by 100, I'm trying to avoid using a nested if, basically. But, let's do it. If it's divisible by 100 and the year, but also divisible by 4, there we go. Then return 365. Else, just return 366. Maybe that's it. Will that pass? Let's just test that. Huh. I'm a fool. Right. The year 0. I'm so glad of this. Right. The year 0, when divided by 4, does equal 0. So it wouldn't pass that test. It is divisible by 100. But dividing by 400 does equal 0. So that year 0 should have returned 366 days. Right, so let's just put in a print thing here. Print, and we'll just convert it to a string. 0 mod 100. What does that look like? What's 0 mod 100? 0. Why are we not getting the test up here? 2000. Why is that not printing out up there? What am I doing wrong? Again, that year's 0. I'm being daft here. 0 mod 4. Like, what does that come out with? What's 0 mod 4? Is 0 can't import name, year, days from solution. Alright, fair enough. 0 mod 4 is 0. So what's the problem with my little test here? If year mod 4 does not equal 0, print 365. Alright, well, let's do it the other way around. Let's just say, what happens if it equals 0? $365 should equal, yeah. What is going on? Is this a Python thing or is this a me thing? Because I'm saying if it doesn't equal 0, this is madness. Can't. It's got to be a me thing. If year mod 4 equals 0, then print out the year mod 4 and return 366 days, right? Oh, I'm not returning the right string. Oh my god, has X amount of days. Right, okay. That makes sense. Right, fine. And I'll be able to, right, okay. I see what's going on here. So, if year mod 4, I didn't follow the instructions then, obviously. Return str year plus as, and then I don't know, something like that. Oh no, as 365 days. All right, I'll just do that as a quick test. Okay, so now then we move on to year 0. Now if the AND is divided by, return str as 366 days. Wait, that's still going to capture everything though, isn't it? It's not going to be right for minus 300 yet. It's not going to be right for the centuries. So if the year is a century and it's not divisible by 400, okay, all right. If then we should be returning it 365 days, and every other case is it's a leap year. Okay, let's attempt that. and that's it all done. Okay, well that was just a case of reading the instructions because it was expecting a certain output and I was giving it something entirely different. So just to recap, is there any little bit of refactoring I can do here? I mean, what I could do is return the same string, but basically use different variables in the string, like yeah, I could do that actually, couldn't I? I could have a variable here called leap, or just days, all right? Days equals 0. We set days equals to 365 if it's not a leap year. Oh yeah, except you won't jump out on that, but it doesn't matter. If the year is a century and is not divisible by that, we're going to set days to that. Otherwise, days will be set to 366, so we just default it to being 366. And now we return the string plus year has, and then here there is a way to like. I mean, I've done this before, but it's like formatting Python strings, and I can't quite remember formatting Python strings. Let's see. I think you can replace it with the variable. I think if I do that, it's not going to work. But if I then do a dot format, and then I think if I just put in the variable here of days, so this doesn't need a name, it just has that place. Okay, all right, it's a little bit neater. It's not hugely neat. Could this be under one line? If it's not divisible by 4, or basically if it's divisible by 100 but not divisible by that. So we're going to assume it's a leap year unless it's not divisible by 4 or that. So it won't bother even executing that. I think that'll still work. It has worked. Okay, so we've got even further like down now. I think that's it basically. I could just put that on the same line really, I think, in Python. Okay. Let's attempt it. Right. So, all right, I mean, I bet there's somebody who's got even smaller amounts, even just trying to think, how can I get rid of the necessity of this variable? Because that would reduce like memory allocation. I wouldn't need to use as much memory for this little thing. I'm always going to have to return a string. Could call a function and pass through the variable, but I think that'll do. That'll do. Okay. Percentage D as percentage D days. Well, that's a neater way of formatting things, isn't it? Oh, they've done it pretty much the same way as I've done it, except the opposite logic. They've assumed it's not a leap year unless the year is divisible by 4 and the year isn't divisible by 100. Okay, or the year is divisible by 400. So it's pretty much the same way. That's I don't know what the term is. I'm just trying to think. I suppose English isn't my strong point, but I suppose the word I'm looking for is vindicating, maybe? I don't know. Validating. Okay, cool. Right, so that's for days anyway, some days in the year. Let's do multiply the number now. So I'll just copy that as usual. Okay. Multiply the number. Jack really likes his number 5. The trick here is that you have to multiply each number by 5 to the number of digits of each numbers. What? Jack really likes his number 5. The trick here is that you have to multiply each number by 5 raised to the number of digits of each numbers. That's what's confusing with each numbers. So for example, multiply 3. So I have is equal to 15 is 3 times 5 raised to the power of 1. Multiply 10 is 10 times 5 raised to the power of 2. Okay. 200 is 200 times 5 raised to the power of 3. All right, that's reasonably quick, I think. Now, I don't know what happens when you get passed an integer and you just print the length of that integer. Like, can an integer have a length? No, it has no attribute length, which is a shame, because why not? Oh well. Okay, so let's print the length of the integer when it's been converted to a string, all right? Okay, so convert it to a string there. Oh, it was never closed. All right, fine. Sometimes it closes them when you don't want it to. Sometimes it doesn't. Okay, so we're printing the length of the strings. I like it. All right, so all we have to do now is raise the power of that number. So, and then just take that bracket out. Okay. So we return n multiplied by 5 raised to the power of the length of it coming in. Like, oh, minus 50 should equal minus 10. Oh, interesting. Multiply. I like these test cases. They're well thought of as well. So multiply minus 2. Oh, okay, but we need to remove that minus sign, don't we? Okay. And then use it back again. How can we remove that minus sign? Keep it all one line of code still. Okay, so I don't know is the answer. So if the string of n position 0 is equal to minus, then we'll just return that times that, the length of the string. So minus 1. Else, turn that without the minus 1. Is that what it's looking for? It is looking for that. Okay, all right. It's not the neatest thing, but that's just saying, is there a minus sign in the integer that's passed to me? And if there isn't, the other way to do it is to just say if n is less than 1. That's well, yeah. I mean, if n is less than 0, all right, that'll do it as well, because then it would have a negative on it. I just don't like having to use duplicate lines of code. If n is less than 0, I know what, we'll call this an adjustment. Adjustment is 0. If n is less than 0, the adjustment equals minus 1. All right, and then all I do is I just return the string minus the adjustment. Okay, something like that. Right. Okay. So I mean that's 3 lines, which is better than 4. So that seems to have done it. Let's submit that. And oh, okay. So they've used an absolute, I think, like I want to call it modulus or a modular function where it ignores the sign. But okay, all right, that makes sense. ABS. I think that stands for absolute, an absolute value. Okay, cool. All right, that makes a lot of sense. What's annoying is I can't seem to go back and find my own solution somehow. And then just make a note against my own solution for self-improvement reasons. Really? Otherwise, I'm not really learning anything. You know what I mean? I'm just documenting what I know, not really improving what I know. Come on, come on, come on, come on. What is going on there? It's taking ages to load up there. Let's give that a miss then. Okay. So this will be a cool little one. Nothing too. Again, I'm not too keen on strings stuff. I really don't like messing around with strings, but it is what it is, I suppose. Grasshopper combined strings. Create a function named combine names that accepts 2 parameters, first and last name. The function should return the full name. Okay, all right. So it's not very. I mean, for me, well, we'll see. What are they doing? They're calling combine names. Okay, and then we're going first, last, and then all it does is return first, last. I think as will that return them as 2 separate variables? It will do, won't it? But they are both strings. Oh well. Let's do it this way. That should just return it as a string of 2 names. Okay, that's done. Wasn't very interesting, that one, I have to say. That's exactly the same as mine there. Not exactly the same. Oh, right, flick switch. That sounds like it could be more interesting. We'll see. So flick switch. Create a function that always returns true/true for every item in a given list. However, if an element is the word flick, switch to always returning the opposite Boolean value. Okay, so it'll just return false for the remainder. Oh, okay, all right. Flick will always be in lowercase. A list may contain multiple flicks, switch the Boolean value on the same element as the flick itself. Oh, so over here it will flick to false and then it flicks back to true. Oh, okay. All right, that's not too bad, is it? Really? This can all be done in one line, I think. But I'm gonna announce this Boolean value here. Flick is true. All right. You see, that is a Boolean, yeah. Back here. Okay, that's cool. So rather than a string, that's what I was thinking. So flick is true. And then all I'm going to do is return, well, I mean, the first thing to do is build up an array. So return array, this is what it's going to be called, is that, right? And so for element in list, if element is flick capital. Now, how do you flick over a Boolean value? Actually, this is why this one's useful for me then, because I could handle it if it was a 0 or 1. So, but I don't know in Python. I think I just do a not or something like that. Change Boolean value. It's probably something really, really obvious that I just forgotten. This is how long ago it is. Right. Yeah, but how? Okay, so I did say it would probably be a not, but how do you do that in just the least amount of code? So in Python, it says here Boolean is a subclass of integer. So for me to do that, then I just have to say the Boolean mod 1, I presume. Oh well, if element equals flick, then flick equals not flick. All right, we'll just swap it over. Right, and then return array dot append whatever the value of flick currently is, and then just return the return array. Return array, something like that. I'll just test it. If element is flick. I've not used the assignment operator, I've used the equals. Okay, that seems to have worked, but I want to do it all in one line then, really. I'll leave somebody else to figure that one out. Res state is true for in. Okay, all they've done is declared the two variables on the same line. Res.append. They're pretty much the same as me, really. Oh, this is the one that I'll be looking for. So return an array where each element in the array. It's that little operator there that I haven't used in a while, that hat operator. That's the nice one. The v in, okay, yeah, that's the nice little function there. Just get my head around that and that, which are two things I need to look up. Actually, I'm just going to put Python the hat operator and this. Let's just have a quick look at that then. So if I say Python I presume that's an operator, not a comparator or something like that. Yeah, it's not that. Unless that's a raised to the power. Oh, okay, that's XOR, bitwise operator. Okay. Right, so that's what he's doing to flick the Boolean value then. And then what's this thing here? So let me just make a note. There's XOR. Don't use bitwise much. Okay, well, I don't know why that's not coming up. Python. Allows for a valid operator that allows for assignment of variables within expressions. They said pseudocode here. I don't think it is pseudocode, what we're looking at. Okay, that's my answer there. Okay, those are my notes done anyway. Right, on to the next then. So that was the flick switch. Find out whether the shape is a cube. Ooh. find out whether the shape is a cube. To find the volume, centimetres cubed of a cuboid, you use the formula the length times the width times the height. But someone forgot to use proper record keeping, so we only have the volume and the length of a single side. It's up to you to find out whether the cuboid has equal sides. Right? It's a cube. Return true if the cuboid has equal sides, return false otherwise. Okay, I like it because it's got some maths in it as well. Okay, so they will pass through the volume and the length of the side. Okay, so I've got to basically do a test to say when I divide the volume by 3, does the remainder, so like minus 12 and 2, well, let's get a true one. Yes, 8 and 2. Okay. So all I have to do is say if the volume divided by 2 right, so we do the volume divided by 2 itself divided by the side length. So the volume divided by the side equals a side. Return true, else return false. Okay. Is that not? Am I missing something here? Totally missing something. Right, minus 8. Ah. Can we ignore? Okay, well, it can't be a cube if it's got 0 volume, can it, for a start? So, oh, that's an interesting one. That really messes up my test, doesn't it? Because, oh no, that one's all right. 0 and the 0 side length. Okay, so as long as the volume is greater than, does not equal 0 for a start, and that return true, right? Oh, does not equal O. That's a bit weird, isn't it? Right, as long as it doesn't equal 0, and then we've just got to deal with this case here. And I actually can't think of a negative volume cube, really. If it's got a negative volume, then each side is minus 2 times minus 2 is 4 times minus 2 is minus 8. So why would that be false? But the minus 12 with the 2-sided worked out fine. Maybe we can't have a negative-sided cube. All right, so let's just say and the side is greater than 0. What happens when the side is 0? I don't know, but let's just test that. Let's attempt it. That's passed it all. It's a bit mad, really. Okay. What I could do is just return that, can't I? If I return that statement there, and I attempt it all, bingo! It's done it lovely, actually. I'm done a single liner, apart from the name of the function, like for a while. Ooh, I'm being called for a game of Catan. Let's just submit that. Yep. And okay, they've done it that way. Just the cubed root. Return if 0 is less than the volume. That's a bit of a weird statement, that. Okay. Right. Cool. I'm going to kick it. Thanks for watching. Take it easy. And I'll be back with some more of these as well.